actual microphone made of metal. It's a cool concept nowadays. My name is Dave, call sign WB0GAZ. I've been in Denver originally from Six Land, but got here in 1971, still waiting my green card, and got my license the same year, WN0GAZ. I remember distinctly getting this envelope from the federal government in 1971, opening it up and just being absolutely thrilled after misfires with walkie-talkies and other things in prior lives. Got interested in radio communication when I think I was 8 years old in Sacramento, and the kid across the street from me got a flashlight, and so did I. I'm sure our parents were colluding, and discovered the day of Christmas in about 1960, let's say a 67, no, earlier, 64 or 65, flashing the flashlight back and forth across the street. And something just got me that is what I want to do for my whole life. And I did, and I ended up getting an engineering degree, and unfortunately ended up working for cable TV companies, which meant I was actually just a purchasing agent for 40 odd years. It was no fun. So after escaping from that type of prison in 2018, left my last day job, and was really worried about not working for about 6 hours. That was the end of that. And then I said, I'm going to go be an engineer for the first time. And as it turns out, learning RF as an engineer coming not from that field with some ham radio background is sort of okay until you get into the details. And somewhere I'm searching online the kind of test equipment I need to build out my lab, which remains here to this day, and stumbled into something called a vector network analyzer. Said, this is how you measure, this is like the digital multimeter for RF. Practically what it is, it's a useful tool. They were really, really expensive. I was looking online. I'm going to try this for the first time. So a little bit of lag, there we go. Looking at one of these things and discovering these things are thousands of dollars, which doesn't work too well if you're permanently unemployed, as people of a certain age tend to be. I have a couple of these in my pile of I call it my walk-in junk box. My wife is very tolerant of this because she's a woodworker called a wood turner with a lathe. So her walk-in junk box is this vast pile of wood, and my walk-in junk box is this vast pile of electronics. And thus we have been for many years quite successful. Bought an Autech RF analyst, little things, kind of pocket size. Carried in my pocket one day, kind of hit the door jam as I'm walking into the house. That was the end of that. Replaced it with an MFJ something. Wasn't quite the one on the diagram there, but it sort of met the goal. And I could go out there and adjust antennas. My antennas these days are just some wires hung up in the backyard of the neighborhood, just one notch east of here. And used to lived in Douglas County, had 2 towers, monoband beams, and the rest of it, and decided when we moved to this neighborhood in 2003, I wasn't going to have an antenna anymore. I couldn't maintain myself. So bring me a roll of magnet wire, that was it. The gist of it in the world of antenna analysis is when you put your MFJ in your shack through the coax up to your stacked monoband beams at the end of a 120-foot tower, that's common here. What you're really reading is the SWR reading through effectively including the coax. And that diminishes the accuracy of readings. You probably don't worry about it too much on 160 or 80 meters, but by the time you're on 10 meters or 2 meters, that hunk of 100 and some feet of coax makes a big difference. It makes the SWR look better than it might really be. The other problem is that you go up, and then I read an article that was in QST, must have been mid-1970s. It was getting the best SWR can kill you. That's pretty dramatic. But what the gist of it was, climb your tower enough times, trimming your antenna, you're likely to fall off the tower. They can kill you. So the real goal is to measure the SWR of your antenna at the feed point of the antenna. So in the lower part of the picture here is my friend who, not me, but would climb to the top of the tower, and that's not really a person measuring SWR, but you get the point. You can carry your MFJ, whatever, your Autech or whatever, up the top of your 120-foot tower, measure SWR, and then shinny out the boom of the antenna, and then kind of work your way out the end of the element. Pull that element in a little bit, put that element in a little bit, and get your SWR improved. But you'll kill yourself in the process. So enter something called a vector network analyzer. And this presentation is primarily about what it means in the world of the AUTEC or the MFJ or any of the other divining rods we use traditionally to measure antenna results. So that's kind of the thing you can use on 20 meters to get your wire pressure. That's my current situation. When you use a vector network analyzer, you're doing things in two steps. First of all, you're going to measure the feed line itself. And you can do that in the comfort of your own shack. You don't have to go up a 120-foot tower. You just put that amount of feed line on the table and you go through a procedure and you measure that. And the little machine, the NanoVNA, we'll talk about more in a few minutes, it records that information, stays it in digital memory. And you turn around and you say, now I'm going to take a measurement of my stacked monobanders on top of my 120-foot tower through that hunk of coax. And I'm going to get a reading just as if my MFJ took that reading. It's a little bit impaired by the effect of all that coax. Here's the cool thing. The NanoVNA and all these vector network analyzers, they can subtract or remove the effect of that 100 odd feet of coax as if you are at the top of your tower, but you're actually on the couch by the fireplace in your shack taking measurements. That can be a useful thing. And so, learning that, you've got to get me a vector network analyzer. And I go online and I found one. This was back about 2019, and I'm shopping around. And I like that. Lots of pretty screens and nice buttons made by a reputable company and about the size of a microwave oven. And it's only $897,000. The reality is these machines traditionally are terribly expensive. Until about the year 2010, your options were to go to Hewlett-Packard is the ancestor of this company, but before Hewlett-Packard got rid of all their brains, this is what they did for a living. And you could buy one of these. Actually, I did eventually buy not that one, but I bought one for my home shack. It's about the size of a microwave oven, and it weighs about 30, 40 pounds, and it does very nice, but it's really a pain in the butt to haul up the top of the tower. Another thing is, I came from my 40-odd-year career in cable TV company. It was called Charter. Don't use them. I don't think you can in this state anymore. Maybe in Colorado Springs they were for a while. Not a good place to work. Not a good place to be a customer. But you live in the world of local area networks, corporate IT departments, and other things that I'd really like to forget about. Mostly have, except my wife's built-in IT department. I don't mind that. The network analyzer, if you go somewhere and you search for one, you may run into something which is designed for IT people. And you connect the computer here to the data server there to the switch here. That's not the kind we're talking about a network analyzer. We're talking about an electrical network analyzer. So that terminology got stolen by the ratty IT people. They use the same term, but us hams, we like the electrical network analyzer. So let's see, let's fast forward to 2019. I have traditionally made a car trip. I have not flown on an airplane now for 15 years. I'm a little tall, I don't fit very well, so I'm not going to do that anymore. So I get in the car, and my wife's very supportive, drive to New York, see my brother, and come back by way of Dayton, Ohio. And I like Dayton, Ohio for the obvious reason. It's a big major ham convention, several tens of thousands of people. As it turns out, and I often arrive coming back with a carload of whatever was a nice treasure to find in the flea market, which was the thing I enjoyed. Those treasures will be buried with me in a bunch of ocean-going shipping crate containers out of the stuff. So I'm back in the hotel, and I'm lamenting that I didn't really find anything at the Dayton flea market in 2019. I think they had just changed to the fairgrounds out southeast of Dayton called Xenia. It's a county fairgrounds, and ham radio to me is mostly an indoor hobby. To have the flea market outside when it's raining in a pile of mud up to your ankles, I kind of like, I didn't. And I'm back in the hotel room, futzing with the computer, and I ran into this thing. I'm looking on eBay. I want to find something on eBay I like for my ham station if I can't find anything at Dayton. And I bump into this It was about, at the time, a $50 vector network analyzer. That's got to be a typo. So I ordered it, and it came from China. It shows up in about 2 weeks. Didn't quite beat me home from Dayton, but it was close. And I opened this thing up, and it's about smaller than that little Autech thing. It's kind of cigarette pack size, had a little color display. And from everything I knew about vector network analyzers up to that point, that was an actual real vector network analyzer, and could stand relatively shoulder to shoulder with this 35, 40-pound Hewlett-Packard machine from a couple of decades before. And I said, that's cool. And so started learning about it. And so first thing is, I could use it to measure antennas, kind of like the MFJ one, but a little more sophisticated. Traditionally, I take my Drake. I love Drake gear. I've got several of them, Drake TR4 and that gear, mostly vacuum tubes. You could measure SWR with your Drake gear, but you didn't really need to when you had an antenna analyzer. And it only sends 100 microwatts out. It's good for not QRMing band. In fact, you can't engage your Drake TR4, which is about a 200-watt output at full power, and the tubes are fresh. When you stick it through your MFJ, your NanoVNA, it will just simply let all the magic smoke out. That's the end of that. So don't do that. What sets from an operational perspective, regardless of what's inside the thing, what sets it apart from the MFJ or Autech or Heathkit grid dip oscillator or E.F. Johnson grid dip oscillator or divining rod or other instrument we tend to grow up with, is you have to go through a separate step called calibration. And this is the operational barrier of entry if you've never used one of these things before. So I didn't have to calibrate my MFJ. I didn't have to calibrate my grid dip oscillator or my divining rod or anything that came from the 1930s. Never had to do that. Why do I have to do this here now? Well, you do. What's happening is the little NanoVNA is free from the restriction that it is self-contained. And how do I say that? The circuitry that's inside the MFJ or the Autech or anything else is kind of soldered into the circuit board, its frame of reference. In the case of the NanoVNA and vector network analyzers, it's not, they're separate parts. And if you look, and I'm going to assume that a portion of the people here have seen a NanoVNA, probably own one because things are down to $30 or $40 or $50. Pretty popular. And when I wrote this slide deck, they were new to people, so it's a little bit aged. But if you've got your NanoVNA towards the left end of the screen, there's some letters that come up. And if those letters aren't there, it means the NanoVNA is not calibrated. It's working. It's actually kind of at a disadvantage because it says, I'm going to make these measurements of my antenna, but it didn't know anything about 50 ohms. It could be, and so it's a little bit at a loss. So when you bought your NanoVNA, or if you do buy one, you're going to get these 4 little tiny parts, and those things called a calibration kit are actually a little smaller than what's in the photograph there. They're about a 5/16 of an inch cylinder, about 3/8 of an inch long. For the things you could swallow them, it probably wouldn't hurt you. Don't recommend that. So you've got this thing. So what were these extra parts that came with my NanoVNA? And it says, well, they're there for calibration. Now, I'm not going to tell you how to calibrate an NanoVNA here. I'm just going to more say what happens, what does it do for you? Well, you stick those 4 devices onto your NanoVNA one at a time, following the instructions on the screen of the NanoVNA, and it pulls in information about those 4 little devices, and it stores those in its internal memory. And so that's a cool thing because it now knows a perfect antenna is equivalent to those 4 little devices. What they really are is a dummy load, a short circuit, an open circuit, and a little tiny section of coax. But in a nutshell, when it does its calibration measurements, it is expecting that those 4 little devices are, we'll say, perfect, like a perfect antenna, 1-to-1 SWR, across DC, whatever band range you're covering. And it stores those in its memory. And in fact, you can tell it now, not only store those in your memory, but save it for someday in the future. So if you do nothing else, you go through this procedure, you say save in one of your storage memories. So when you turn it on the next time, you don't have to go through the procedure. It only takes a few minutes, but sometimes it's nice not to have to do that every time. And so why are you doing the calibration? Because this is the crux, kind of the crux of this chapter of the story. The NanoVNA is a comparison machine. Vector network analyzer's job is not to make a measurement of SWR or anything else. They're to compare perfection, which is those four little devices, with whatever your antenna is. And where this comes in valuable will show up in a minute. Back to that venture of, well, why do I take the, how do I run the equivalent of having to crawl up my tower when I can take the measurement from the comfort of my shack? Is the software inside the NanoVNA goes through a big wad of calculations and creates what's called correction data. Now, if I go back to that example at the very beginning where I've got my monoband beams at the top of a 120-foot tower, come back through a couple hundred feet of coax and end up coming back into the shack. If I do that calibration, including that length of coax, then that correction data is specific for that length of coax, which means when it goes through all those calculations, it removes the effect of those coax, and it's if you're climbed up to the top of the tower making your measurements up there. The result is you get readings that are corrected for the effect of coax or switches or whatever other stuff you've got between your shack and your antenna. That is called a correction process, and it's just a big wad of math, and you don't have to worry about it. The NanoVNA and all those machines that are called vector network analyzers, that's what's inside them. It's a pile of software doing this big pile of calculations. Traditionally, when you went to buy a vector network analyzer like that one for $897,000 from Keysight, please buy me one for Christmas if anybody here is so inclined. You're really just paying a cost for a pile of hardware, but you're also paying for their pile of software, which is actually just doing the same type of calculations that are occurring inside their $40 NanoVNA. It's very standard calculations. So we'll get to how did that come about here in a couple minutes, but if you ever want to use twin lead, 300 ohm twin lead ladder line, buy that stuff, you can build your own. You don't get a calibration, you don't get those four little parts for it, but this is just to show you, you can make your own. You take about a half an inch or 2 inches of twin lead and you put a short at the end of one of them to solder the wires together. You leave another one open and you put a 50 ohm or 75, 300 or 400, whatever the impedance of your feed line you want. And that becomes the calibration kit. So your NanoVNA, even though it's got a coaxial connector on it, can make measurements based on twin lead feeds to your off-center fed dipole antenna, your ZEP or whatever you're using, because you can make your own perfect antenna, which is a piece of twin lead terminated by a resistor of the same resistance. So nothing real magic about it. I'm kind of jumping around here. This is going to end sooner than the time we've got until just before 3 o'clock. So either we get to escape early or we get to a few questions. I didn't bring it demo, but so such as it is. I do want to talk though about SMA connectors. The SMA connectors are the little things I'm describing. They're gold colored. They're sort of like a PL259 or SO239, like the UHF connector, but they're a lot tinier. Yes, sir. You want to show? I brought one. Maybe afterwards you lay it out somewhere people come up and look at it. But the SMA connector is something that will be less familiar to most hams, especially those hams of a certain age like me who grew up with typical PL259, SO239 connectors. These are becoming popular on the new handy-talkies, VHF, UHF, but they're still not real familiar. So I wanted to talk about those. This is not quite relative size, but it does give you an idea that the SMA connector is smaller. This type of connector was created in the 70s, 80s, 90s, mostly for microwave applications for defense armaments. Became popular in laboratories and eventually kind of works its way out to the ham community, but still isn't real popular. We're mostly dealing UHF, which has nothing to do with band UHF, might have, but the name comes from long, long ago. So the reason why I mentioned this is when you get your little $40, $50, $60 NanoVNA, you're going to see a pair of those SMA connectors hanging off one side of it. One of them you use a lot more than the other, which is how you make antenna measurements. And the first thing you might be tempted to do is go out and get yourself an SMA to UHF adapter, because you've got your coaxes coming in over RG8, RG213, LMR400 to a PL259. some of this coax it's all very heavy. It's not very flexible. And basically the coax weighs a lot more than the NanoVNA does. And so if you encounter this circumstance, please don't do that, which is you can buy these things, especially from the Chinese vendors. Attach to the end of your NanoVNA, plug your PL259 in there, and the minute you grab the two of them, you're going to break the NanoVNA because that connector, that little teeny gold connector, is just soldered to a circuit board. In fact, that's why these things are so cheap traditionally, is if you look at one, it's a piece of circuit board material, which is the front panel, a circuit board where the guts is, and another piece of circuit board in the back panel, and that's all there is. In fact, you stick a wire on the side of the thing, short it out, and let the magic smoke out. So mechanically, that's the price difference. One of the factors in price difference between a $40, $50, $60 NanoVNA and an $897,000 Keysight device. Use instead a little flexible SMA patch. It'll break the torque that happens between your RG8 and your NanoVNA and prevent those from the NanoVNA being susceptible to damage. Here's something that someone did. I ran into this person out in Six Land here some years back, built a little carrier for the thing. And that way the mechanical torque of your feed line is absorbed by a little thing made it out of circuit board. It doesn't affect the readings enough to be a problem. One other thing is that the NanoVNA, those little SMA connectors, the rule of thumb in those is finger tight and a little bit more. It's actually measured in inch pounds. Don't go out and buy a torque wrench. Don't use the torque wrench that you use for tightening the lug nuts on your car. A little bit overkill for that. There are torque wrenches you can get for the 5/16 inch flats of an SMA connector. It's not really worth spending the money on it, but it's basically be cautious not to over or under tighten. And so the rule of thumb I found over the years I agree with is finger tighten a little bit more. Let's see, do we get this? There we go. Another gotcha about SMA connectors. This type of connector was adopted when Wi-Fi emerged and you could buy a Wi-Fi router for your house. Go to the computer store. This got popular in the 90s. But they decided to make they use a version of an SMA connector called a reverse polarity. You look at that, and you look closely, you'll see that the little hole in the center of the one on the upper left is now occupied a pin. And the little pin on the lower left is occupied by a hole. I can tell you from personal experience, if you plug the wrong kind in, you will destroy both the connector and the thing you're connecting into. It's been there, done that, didn't work out too well. Just be aware of that. So I'm jumping ahead here, your own NanoVNA. Okay, this is kind of do what I did when coming back from wrapping up the invention in 2019 online. And well, there is no NanoVNA company. That's a little bit peculiar because you can go to Hewlett Packard or Keysight, what they call themselves now, or any of these other companies, and you can buy a product from the company. You go on the web, the company's got a website, and they'll tell you, in fact, if you send your contact info, you'll have 4 suited, jacketed, or 4 salespeople in dark suits and coats come up to your front door, like happened to me once when I'm a teenager, and sent off for free samples of something from Texas Instruments. My mother was very concerned. Well, the NanoVNA was originally developed by somebody who I believe is in Japan, who goes by the handle, if you will, kind of a self-assigned identifier online called EDY555. And I didn't quickly find the name of the person or where they're located, but they had done this design to build a very low-cost vector network analyzer that would be good for somebody out of $40, $50, $60 rather than thousands and thousands of dollars, but didn't ever get it to market. They wrote software, they made a hardware design, and that was kind of as far as it went. Somebody in China who made themselves another identifier, not the same person, goes by Hugen, Hugen 79. I would presume 79 is probably the year of birth. Person does appear on email occasionally, got an outlook.com email address, but it's just a person who took the work that Eddie 555 had done and said, I'm going to make this into something that could be manufactured. They took the software, did whatever they had to do with the software, laid out circuit boards, and made it sort of into what you typically get now for a NanoVNA, which is this circuit board for the front panel, circuit board for the back, and material, and then the circuit board with guts, and it's all, 3 by 4 inches, very tiny and low cost. And this design was eventually manufactured in China at some unknown anonymous factory or factories in China. I I've never been there. I don't know quite what the mechanism is, but there is not, when you drive up to one of these factories, you're not going to see anything. Go ahead, sir.
Yes, I have a NanoVNA, which is a little aluminum case, and it has no screen. You're supposed to communicate with some sort of Java program.
Right.
And are those still supported, or now it's picking up the screen?
No, there are, I'll call it headless VNAs. And a brief detour, the NanoVNA, there's a software program that runs on a PC called NanoVNA Saver. And I didn't add any details because I forgot, frankly, how much time I had today, so that's left off. But there is software that runs on a PC. You attach it by USB to your NanoVNA, and the screen on your NanoVNA becomes kind of unnecessary. In fact, it doesn't even need it to operate. So it is possible to end up, I've not seen one, but that is actually a NanoVNA with no screen attached. You connect it by USB to a PC or other home computer or laptop and run this NanoVNA Saver. Is by far the most popular code out there for that purpose. And it does two things. First of all, you're dealing with a larger screen and a keyboard and a mouse, which is handy, but not really good if you're climbing up the top of your 120-foot tower. But it also, because it takes advantage of the extra processing power and storage in your PC, can give you a wider range of measurements because it is electronically controlling what the NanoVNA itself would do at the end of the little tiny screen. I would say that the NanoVNAs without a screen are much less common. What did happen after about the first year is people were getting really frustrated by the 2.8-inch little LCD color screen, and they emerged in a 4-inch size, like that. It makes a big difference for somebody like me who's very good at fat fingering things, and they were not terribly more expensive. Well, the 2.8-inch, it turns out in China, the factories that would do these things anonymously were just using a viewfinder from a common series of digital cameras. And it was very cheap. The mass manufacturing was the digital camera. They just harnessed that part and said, we're going to use this. There's a whole world of interesting electronic parts you can get from China, and they're just a little risky to buy something for. They're asking me had that happen sometimes, but to be able to play with your own little LCD display for homebrew projects, kind of a cool thing in this era. Fortunately, although there's not a NanoVNA company in the U.S., we deal with you can either buy the thing online over eBay or another mass merchant platform that works out of China called AliExpress. eBay, relatively safe. AliExpress, extremely not safe in terms of resolving problems. Don't go there unless you really want to have an unhappy adventure. But there are, you can go to Amazon, you can go to Walmart. Very surprised to discover a lot of electronic stuff for sale on Walmart. There is a ham company, though, called R&L Electronics in somewhere in Ohio. I've forgotten the name of the town, RAMDL. You search online. And they have become kind of the go-to place to buy this type of equipment in the US, primarily marketing to hams, and they will assure the quality. In fact, I bought another called a Tiny SA spectrum analyzer, and after about a year, it developed a problem, and I way out of warranty. I bought it from R&L, and I contacted them, said, "Oh, sure, send it back. We'll send you another one." And what will that cost me? Oh, nothing. And I did, and they did, and I was astonished. And so I can speak highly of them. It's sort of a good customer experience. There's so that you can buy the device through a variety of channels. The R&L is probably the least risk. Amazon's a relatively low risk, and it gets more involved from there. The price tag for the original 2.8-inch version would be two-figure money. The fanciest ones you can get that cover a little wider frequency range, a little larger display, you can get up in the $100 and some. There are a few of them that now have 7-inch displays. They get up into the $400 or $500 or $600 range. I would say don't overspend on it. but very handy thing to have. So again, without the company, where is the engineering department? Well, it turns out the engineering department are a few very talented people who go by more anonymous names online. And this is just how it's done now. One of them uses the signature DISLORD, apparently from Eastern Europe somewhere, and learn the guts of this thing and will publish new software you can push into your NanoVNA that adds features or improves function. Don't know who the person is, but they've sure been active for the last 4 or 5 years. Another one goes like OWOWOWOWO123. So a woman apparently in China who's a very talented RF engineer. Don't know that she's Chinese, don't know where she's from, but she's ended up taking on to build more capable versions of NAT that you look outwardly at NanoVNA, but it actually can go to the holy grail was to get up to 6 gigahertz so that it could cover the frequency range of all the Wi-Fi bands. And started a little company and we'll sell these things to you that way. Another resource to be aware of, not really a place to buy it, but a wonderful place to get advice and learning, exceptionally valuable for beginners, is called NanoVNA-usersgroups.io. And I'll tell you a little story about that. I'm sitting back in my hotel room in Dayton, Ohio, actually in Fairborn, where the QRP group that I would hang out with had their annual session, and deciding there's nothing from the flea market I found. It's 2019. So I'm going to buy one of these things. And then I realized you can't go anywhere for advice. And I had just learned about groups.io, which was at that point in 2019, a company that set up user communities for free. And I go, well, that's all right, I'll call it NanoVNA users. And initially I was the first person because I was the one that set it up. And I get back to Denver and there's like 50 or 60 people on it in 4 or 5 days.
I was one.
There's now 13,200 people on this.
Wow.
Now I kind of retired. I never really wanted to run NanoVNA user. I just wanted a place to go for advice. Well, a buddy of mine up in Louisville, since moved to Florida, had some experience with other groups on this, and he said, "I'll help you out." And then early this year, I said, "Okay, I don't want to be in the line of fire. Would you go find a third in command, and I'll kind of retire." And after a few back and forth emails, we got somebody who now lives up in Loveland. Is the other, so we now got 2 group owners. It's very well recommended. If you can access it with a web browser, it costs nothing. They do pass the hat every year to fund the operation of the group, which is like $200 or $300, and the first 10 people commit out of 13,000. Don't worry about it; you don't have to pay a dime. And the group has, sometimes technical groups get waylaid by unrelated discussions. Unfortunately, a lot of political discussion seeps over into technical forums. This one does not, mainly because if I found somebody that was hijacking the conversation, I removed them. And I did for several years, and that became kind of a typical practice. And so it's a very well-regarded group because it has a very high technical content relative to unrelated topics. A great place for somebody to go get oriented. There's also beginners, books, YouTube video links, software updates, a lot of things. It has turned out it's kind of a big city about NanoVNA. So if you take nothing else away from this, and you've got a computer and you get on the web, go look for that and just go read about it. You'll learn a lot more than I can offer here. And so the 2 co-owners are KC0WJN. His name is Dave. The other recent additionally co-owner is W0LEV. His name is Dave. My name is Dave. So we became known as the 2 and eventually the 3 Daves. Now we're back down to 2 Daves because I'm semi-retired. I'm just the backup in case they both decide to disappear at the same time. Other things that are useful to learn about the world of vector network analyzers. There's a book written by an individual, Joel Dunsmore, The Handbook of Microwave Component Measurements. If you buy it hardcover online, it'll cost you something over $100. It is very well spent money because it is written by one of the key designers of the Hewlett-Packard vector network analyzers, of which that $897,000 box was one of its descendants. Wow. This is somebody who created the one that's in my shack called an 8753. Size of a microwave oven, was 3-figure money when I bought it, and serves well to this day. It's kind of difficult to haul up the top of the tower. This person is a very good writer, and it is excellent bookshelf resource material. if you would like to delve into it in a little more broad detail than might be the case for checking your latest 4-element 20-meter monoband antenna. There are a couple of other places to go. There's an online book called Introduction to Network Analyzer Measurements. It's published by a company called National Instruments, which is a roll-up of a bunch of test equipment companies in the 1980s, 90s. Costs nothing. It's just a couple hundred pages of a PDF file. There's also an electronics forum called EEV Blog, the Electrical Engineering something blog, a forum. It's a big, handy community for all kinds of topics electronic, including RF and microwave. And there is a book on it. If you follow that link, it should take you to it. By the way, I somewhere didn't know if I got my email address into this, but use my call sign at yahoo.com and publish it to the world. They've got adequate spam control, so feel free to drop an email. Probably a good way to reach me. There is another website called Microwaves 101, and you're going to find that VNAs and microwaves are joined at the hip because they are how you deal with these tiny, 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 very exotic circuits when you want to make measurements that you can't probe with a digital voltmeter. But VNAs are not purely about microwaves. In fact, the NanoVNA, the classic one that you can buy for $40, $50, $60, covers somewhere around 100 kilohertz at the bottom end of its frequency range up to 300 or 400 megahertz, maybe 900, I think might be a number. It'll cover all the HF bands. But these things are now exist that go up into the hundreds of gigahertz bands. Not hams aren't really there, but in any event, there's a whole bunch of topics there that I think if you are curious and want to learn more, this website, Microwave 101, is kind of Wikipedia of us RF type people. And I go back to this, well, after I finished my 40-odd years being a sort of purchasing person at a cable TV company and wanted to be a real engineer, I had to go learn things. This turned out to be real good too. Actually, that's it. So my email address is there. Feel free to drop me an email. We are now at sort of 10 minutes and counting to wind down. So questions, comments, rotted tomatoes. Sure.
What is that? Who's that company again that you recommend?
Oh yeah, the question is the company, sorry to not echo, did play the video briefing for speakers and then promptly forgot. So there's not microphones in the back. The company that I recommended for a US distribution for NanoVNAs is called R&L Electronics. 5 letters, R is in radio, the word AND, and the L is in Lehman, RANDL.com. That'll get you their website. I have no business relationship other than I bought things from them a couple of times and they were disproportionately favorable to a person buying something getting lost. And I thought that's a good thing when you're delving into a world, especially where there is no company behind the product. They kind of recreated the recourse of not having a company in them as a distributor. And like I say, when they replaced my failed spectrum analyzer with getting kind of poor quality measurements for free well after warranty, I said, okay, I'm sold. That was what you're looking for? Cool. Sir.
Yeah. I'm going back to the NanoVNA Saver.
NanoVNA Saver.
Couple thousand of the group you started, and since I got in on the first one, they've gone through a lot of different program suggestions for interfacing for the computer.
Right.
This latest one, NanoVNA Saver, is the best one to use now.
The question is NanoVNA Saver the best one to use now? I believe so because I'm a strong believer in safety in numbers. Things that get orphaned are a real risk in the world of technology. If you use Google services for any length of time, you know what I mean. They will discontinue something. And the NanoVNA Saver may not be the best, and I don't know whether it is or is not the best in terms of technical stature, but it's got a very large user community. And a large user community is what makes the NanoVNA users group where people hang out extra valuable. So if you run into something, if you've installed NanoVNA Saver on your computer and you connect it to your NanoVNA and it's not working at all, which is the likely outcome at first, Then you can go back to NanoVNA users and literally post, my computer is this, my software is that, my NanoVNA is this, I plug it together and nothing happens. Somebody will answer, and that answer will probably be usable to you. There are other software programs that can drive a NanoVNA. I can't tell you any of them right now because I don't use any of them. I use my original $50 NanoVNA, never even changed the firmware on it. It still sits and rattles around on my workbench. It's never been changed in 4 years. But I do believe that safety in numbers is real important in the world of technology when we're out there kind of unsupported as hams. Does that help at all?
Yes.
And your question, sir?
Yeah, okay, so on my bigger analyzers, I took.
You got an $897,000 one? Cool. Can I come over and borrow it?
No, my $45 million.
Ooh, we like.
But no, but on my Comet and all those others,
Comet antenna.
yeah, and you know, and the amateur and everything.
Right.
I take a PL, you know, on the dummy loader and all that other
Right.
stuff. I take the PL 259, I cut, you cut it off there,
Right.
and I strip it, and I have a little bit of shield.
Right.
So with this, I can go to shorts and everything else. Plus, the main thing I can do is I can set it up to hook on to 450 ohm.
Right.
And test an antenna with that.
Right.
Without, you know, without going through products connectors.
So you could take the plug-in for the NanoVNA and come out in a piece of coax.
Well, yeah, so
And,
yeah.
and you, so
I have a little plug, just one instead of what they supplied me with.
okay,
So I put a little piece of coax
Coax,
in there.
right.
What is it?
RG58's kind of
No,
common.
well, no, it's smaller, the
The 174 is a flexible.
The 174.
174.
So I took and put a pigtail out
Right.
there, and I can do the shorts and
Right.
the load and everything else on that too.
So you have built a, we'll say an
I
SMA.
don't need the plugs for.
So, what you're describing will work. And let me tell you a couple of observations.
Yeah.
Mechanically, it's going to work fine until it breaks, but anything else can break too. That distance, the length of the coax from the SMA connector out to the little short open location, it is a tiny fraction of a wavelength on 10-meter band.
Yeah.
If you were to operate that same calibration configuration on, say, the 1.2 gigahertz microwave band, that couple of inches of coax becomes a major piece of the puzzle. So it is when I showed on the diagram of some back, I said, don't plug the adapter right into the NanoVNA because when your RG8 will torque it to death, use a little piece of coax. That is true. Effectively, that's arguing what you're doing. It's an equivalent. That length of coax, as long as it's in the few inches, won't make a difference on HF bands, but it will begin to make a difference on microwave bands. But you're not doing microwave bands unless you're me, in which case you wouldn't do that anyway. So what you're describing, fine. Now, with connecting to 450 ohm ladder line,
Yeah, then I can take that and go with alligator.
little clips, clip it on.
Off my 174, I can do 450 ohm coax.
Now that raises an interesting question. When you are calibrating, at that point, you'll want to plug a 450 ohm resistor in as a load instead of 50 ohms.
That would be better, yes.
Yeah, and that, again, you're going to have a little short piece of coax that's severely mismatched, but on the frequency range you would typically use for ladder line, 80, 160, 40 meters, it won't make a difference.
Yeah, so I could do the 450.
Yeah, so what you're describing is, it works.
So it works. Really
Yeah,
well.
and in fact, it's essentially almost identical to the diagram I had up there, which is a short, an open, and a resistor. Just follow the characteristic impedance that you expect your antenna or your feed line to be, which ladder line is often 75 ohms used for twin leads for TV antennas. 300 ohms or 450 are two impedances that are common for you buy a ladder line by the 100-foot roll. Is that kind of the direction?
I bought mine from a friend for $5, and I really love it.
Yeah.
I really. And I downloaded it, just about everything I could on NanoVNA.
There you go. That's a good way to get started, sir.
Yes, I sometimes get into situations where I need to analyze microwave antennas, sometimes Wi-Fi antennas.
Wi-Fi would be a very common case.
Now, the NanoVNAs claim that they will go up into the gigahertz range, but how accurate are they when they get up to that kind of?
The accuracy is almost entirely driven by the quality of the calibration components. This is something which is a good VNA is repeatable, which means you heard the old Einstein saying doing the same thing every time and expecting a different result every time is insanity. A VNA in general, where you make the same exact measurement using all the same electronics, same procedures, and the rest of it, that produces a different result every time, a materially different result. There's something really wrong with that NanoVNA. So the quality of a vector network analyzer, its figure of merit, is actually its degree of repeatability, not its degree of accuracy. The accuracy is established by the fidelity of the calibration components. Your calibration, where you clip lead a resistor to the end of a short piece of twin lead. By the way, again, I didn't echo the question, but the question and the gist of it was, is a NanoVNA going to be accurate at microwave bands commonly used for Wi-Fi? Would be a main example, 2.4 and 5.6 gigs.
I'm looking for SWR to find out if something is going to
Right.
resonate, if it's going to be, if it's shorted, if
Right.
there's something wrong with it.
It is when you go through the calibration procedure, the one thing you'll want to do at microwave frequencies is you'll have coax from the VNA to your antenna, your microwave antenna, like maybe a foot or 2 feet or 3 feet. When you go through your calibration procedure, do the calibration at the end of the coax, not at the NanoVNA itself, because that 3 feet of coax at microwave frequencies will substantially make SWR, which is the main thing you're looking for, look better than it really is. And here's an extreme case. If I've got 5 gigahertz measurements going to the Wi-Fi 802.11a band, and I've got 1,000 feet of coax, of any coax you care to find, the signal, by the time it gets to the end of the 1,000 feet, is gone. It's been converted to heat. And which means that anything you put at the end of that coax is going to look like a perfect resonant antenna, whether you short, open, or have an antenna up there. So the effect of coax between the vector network analyzer and the thing you're measuring, the effect of the coax is to make measurements begin to look artificially good. Now, at 3 feet of coax, you're going to not see an infinite SWR. You're actually going to see maybe an 8-to-1 SWR if you have an open circuit or a short. How am I getting an 8-to-1 SWR at the end of 3 feet of coax is the power that came out of the NanoVNA that went through those 3 feet of coax was lost to heat after 3 feet of coax. It turns around and comes back. That's what the NanoVNA is measuring to look for SWR. And what comes back is further lost a little bit of energy through that 3 feet of coax. The result, when it goes through its calculations, is it will have lost enough signal that the SWR is no longer infinity. It's now just some number. You try this at home, you'll probably produce that result. If you instead take your little calibration components and you attach them to the end of the coax, right where the antenna would plug in, and you go through the calibration procedure, and this, you can buy NanoVNAs that cover it to 2.4 gigs, now some that go to 6 gigs, which means you could do this on 802.11a on 5 gig band. You do the calibration components at the end of that coax. The mathematics now removes the effect, correction process removes the effect of that piece of coax. It's as if the NanoVNA were physically made it to the antenna with no coax. It's a miniature version of that case of not wanting to climb your 120-foot tower to reach the monoband stack you've got. The other thing, when I could say the quality of the calibration components, if my load, which is the most vulnerable, a 50 ohm dummy load, it's part of that little set of those 4 parts. If that one, I hook it to the output of my Drake TR4, little teeny SMA connector hooked to the and I load up on 80 meters, got 200 watts out. Well, it's going to be pretty hot. In fact, it's going to be burned out. If I turn around and I use that as my calibration components, then the NanoVNA, who is expecting a perfect 50 ohm dummy load, ideally out at the end of that short piece of coax, it ain't perfect anymore. And because it goes back to what the NanoVNA is doing is kind of a mathematical comparison of the calibration measurements against the actual antenna measurements. It can't do that properly anymore because the little dummy load, which is key to that, is all of a sudden no longer accurate. And I have done all these things. I've been a HAMS in 71. I burned out stuff. For no reason. So yes, what you're describing is you can get good measurements. A good VNA will be repeatable. Most of them are. A good calibration kit is one that's just probably undamaged coming from the manufacturer. And the process that you'll want to use up in the microwave bands is to do your calibration with the coax at the end of the coax versus using the calibration devices right at the NanoVNA itself. And then you'll be astonished, well, it actually works. And in fact, the coax could be 20 or 30 feet long because the NanoVNA is able, or any VNA is then able to measure the result of that piece of coax and say, I'm going to subtract that mathematically from measurements I'm making with the real antenna. Is that helpful to your question?
It's somewhat helpful. What I'm concerned about though is bandwidth. Do these things really reach? the
Yes,
gigahertz range?
if it's because the internal, and I see two other questions, and I'm going to go quick. The internal chips that they used in the classic NanoVNA went to 300 megahertz. They used a harmonic to get to 900 megahertz. The chips that were used for essentially every version following that went to 4.4 gigahertz. The later version NanoVNAs that you're now seeing marketed at 6 gigahertz part, they use a different semiconductor chip again that went to 5.8 or 6 gigahertz. Those chips were progressively more expensive, so they weren't used in the earliest versions. But yes, you can get to 5 or 6 gigahertz. It will work fine. The factor that eventually enters into is called dynamic range. But drop me an email, we'll yak on the phone. Sir, last questions?
My question was dynamic range.
Yes.
How much of a problem is it? You're hooking up this huge antenna.
Right.
And you've got a whole bunch of RF on it.
Right.
And how do you differentiate that between the signal the VNA is generating so you get an accurate reading?
The power of a NanoVNA is quite low. It's in the microwatts range. And if you're measuring on right around here, we've got that big AM broadcast center. Boy, ask me about it. That thing at 1690 kilohertz is, it appears great on my little homebrew QRP array. It will be confused. It will get impaired measurements based on picking up RF that you have to use it for that one case. You need to use a higher power vector network analyzer.
So is there one you can buy?
Yes, it's made by look for W5BIG, Whiskey 5 Bravo India Golf. The model number is called a VNA 2180. This is in terms of a self-contained without a monitor attached for a PC. They're in the high hundreds of dollars nowadays. They were more when they first came out. Ask me, I bought one. It generates in the tens of milliwatts of power. It sends enough power to the antenna that it's less susceptible to interference from ambient RF. The other thing is do your 160 meter measurements at night because the AM broadcasters that are in our area tend to reduce their power at night. It is a factor, it's not an overwhelming factor. Sir.
Drive someone, what situation can drive someone to look at the next level up?
When would you want to look at a fancier or more expensive NanoVNA?
Applications because you do that.
They're actually very, very little. That's one of the paradoxes of the original low-cost NanoVNA is it will stand shoulder to shoulder with a Hewlett-Packard 8753A. That's my benchtop analyzer. The two are very, very similar in capability within their common frequency range. Going up higher in frequency would be the principal reason you get a different one. But if you're going to work fine on HF and VHF, get one of the low-cost ones. Because if you blow it up, all you're out is the cost of repair or replacement of a low-cost thing.
What about the spectrum analyzer version? Same thing?
They're, again, stay within the frequency range that's of interest to you. The little tiny essays, which are painfully out of time now, are actually a completely different device internally. Primarily what you're getting is higher frequency coverage. That's the dominant specification. It's not terribly relevant because dynamic range in a VNA mostly is important if you're adjusting duplexers for a repeater station. But in terms of, and time is up, yes, I get it. I'm with you. I'm way up. Unexpected, but it is a dynamic range is not very important unless you are calibrating duplexers used in an FM repeater. That's the one place where a VNA dynamic range gets to be important. Last question, Lotto, nobody? tired, want to go home, want to go have dinner. Got it. Okay, thank you so much for your time. Appreciate it. And again, you can order on email. I love to gather on email and I'll answer any questions you've got. And do look up NanoVNA. Thank you and good night. Oops.